welcome back to Cost Electronics. Today I'm working on something difficult. These are two radios from Opel, Vauxhall and maybe Nissan, don't know. As you can see, no buttons, no display, nothing. Customer complaint is his original radio doesn't work anymore, not turning on, nothing. No communication also to the radio with the diagnostic tool. And then he brought me another radio from the scrapyard and told me program this to my car, please. And I said it's not so easy as in the good old days, because these radios are WIN coded and locked to everything. It's horrible. I'm trying to repair the faulty radio from the customer now. And as you know, you can not much do on the desk without the rest of the car. So it's completely blind flight what I'm doing here. But I'm trying, and one of the first thing what I want to do is compare some voltages on this board here. This here, by the way, is the working one. This here is the faulty one. Now I'm powering up the faulty one first, and let's compare the amperage. As you can see, about half of an amp. Then radio makes a restart, current dropped to 0, now again at 0.5 amps, and this goes on and on and on. Now the working one, this here, it's that cable. Oh man, look here. Goes up to 0.7 amps almost. And then drops down to almost 0 and stays there. Yes, it stays. So that's the first clue. And as you know, on these modern radios it can be everything. It can be a software fault or hardware fault. I compare some voltages on these PCBs, both, and hope I can find any differences. Maybe I got lucky. I don't want to bother you with voltage comparisons here on my desk. I show you what I found. Here on this working radio there's a big coil. I hope I can do this on camera with you. Power on the radio. And I have 5.3 volts here. As long as the radio is turned on before it goes to sleep. Now it goes to sleep and the 5 volts are away. Now do this on the faulty one. Power on again. Nothing. I think that can be my problem here. Now the big question is why? Please remember, the voltages here are controlled by the software from the microprocessor, and it doesn't tell anything when you have no voltage here. It still can be a software fault. Okay, I realized that I don't have the 5 volt on this coil here. Now it can be two things. One is a short to ground here, or the driver is bad. This here is the driver. So first I'm doing a resistance check to ground with my meter here. Check ground, 0.3 ohms. Now here (370 ohms, kilo ohms, no, 360 ohms, sorry. And here, as it's not a short, and here less. This is the working board, by the way. About 200, and it jumps. It seems that I'm loading a capacitor here. It goes to about 300, and then open loop, and the game begins again. So not the short. What I want to do next, before I touch this driver here, I want to compare the current when I feed 5 volts with my lab power supply. I set to 5 volts. 1 amp is okay for now. Oh, it draws 1 amp, only 1 volt. Now here on the working board, 0.2 amps and 5 volts. So I have a short somewhere here after this 5 volt, maybe from a regulator that comes next from this 5 volt supply. I don't know yet. I will wire a solder a wire here and see if any part becomes hot. Yes, I do this next. By the way, let's see if there is any action on the scope. Nothing. I solder a wire here and feed 5 volts with my power supply and check if any part gets hot. Maybe this is a clue. Let's see. 5 volt, 1 amp. I was not able to find any hot spot. I noticed something. Here is a burnt track that goes under this capacitor. So next I want to remove this capacitor and see where this track goes. Uh-oh, this track is broken apart, melted apart, and this track goes to the regulator on pin 8. And here's the data sheet. Pin 8 is battery voltage in. To be clear, this battery voltage on pin 8 is the input of the switch regulator that produces my 5 volt here. So I don't suspect a bad regulator now, because the input voltage is missing, and how this thing should work without the input voltage. So I moved my external power input to this pin 8. They are connected to these bigger capacitors to my lab supply, and let's see if I can find any hotspot now. Wow, wow. I found the problem. Here, this capacitor here I have already removed. This stinker here has a short. That's the numbers. 10 microfarad, 25 volts or 50, doesn't matter. Now I removed all three of these capacitors because I don't want that the next blows up and makes the same problem again. I will replace them with better ones. Here I have repaired the burned PCB-Track. Let's see now what happens if I got the 5 volt back. I hope so. Power on. Yep. Wow. Now that's my final repair here. I put in some higher voltage capacitors than original. These are 50 volts, 10 microfarad. No problem with the pads, they are only a bit higher than the original ones. But they don't touch with the bottom plate where this PCB goes in. That's it. I'm assembling the radio now and yeah, almost done. As you can see, no problem with the size of these capacitors. I always install new thermal paste to the audio amplifier. That's the finished product. A radio that I've never seen working, but it should. By the way, here is the number. Thanks for watching. Bye bye.